Oops. All right. So, uh, this is what we talked about on Thursday. So, operations with complex numbers, you should be able to perform operations with complex numbers. Now, you showed me before that you did them pretty well. Okay, so this is the imaginary unit, I, and remember I is the square root of -1, because you can't have a negative inside of the radical in the real numbers. So, that's why it's an imaginary number. Okay, and these are the common powers of I. So if I to the first is going to be I to the second is going to be -1, I to the third is I squared times I, or -I, and I to the fourth is 1. Okay, and it's going to keep repeating that. So to find out like which to find out what it's going to be, like let's say it was I to the 53rd power, you want to divide 53 by 4. Always divide it by 4. So 4 goes into 5 once. All right. And 4 goes into 13 3 times. Sorry. Yeah, 3 times. That's 12. And we get a remainder of 1. So that one is our remainder. So this I to the 13th, sorry, 4 to the 13th, which is basically just 1, because it's 1 to the 13th power, which is still 1, right? Still 1. And then we have I to the first power, because that's our remainder. All right. Now, what is I to the first power? I to the first power is just I. So this one is equal to I. It's equivalent to I. All right. I guess I should put that on the notes. All right. And now we talked about this one when you have an n that's less than 0. So when you have a negative n, it switches. Okay. So instead of, no, I guess it's going to look like this. They switched it already. Okay. So if your remainder ends up being a -3, then it's going to end up being I. If it ends up being -2, it's going to be just like if the remainder is 2, it's still going to be -1. If the remainder is -1, it's going to be just like if the remainder was 3. It would be -I. Okay, so those are equivalent. Okay, and if the remainder is 0, it's still going to be 1. And there you go. I don't know if I should be putting these on the notes, but I will. All right, just in case. So here we want to simplify I to the -10th. So again, you want to do the 10, -10, divided by 4. 4 goes into 10, 2 times, -2 times, -2 times 4 is -8. Subtract, so we change that sign and we get -2. So this is the same as I to the negative second. And I to the negative second is -1. So find the remainder, and then that's what it's going to be. Okay. Yeah, we don't need to put the I to the 4 times to the negative second power because that's always going to be 1. So we just need to put the remainder. Okay. And yeah, for number three we have I cubed plus I to the 20th. I cubed we know is negative I to the 20th. 20 divided by 4 is 5. And that's a 0 remainder. So that means it's going to be I to the 0, which is just 1. And there you go. That's our answer. Negative I plus 1. All right. And so you do the, for the others, I guess let's do number 5. We want to do 77 divided by 4. 4 goes into 7 once. 4, we get 3. Bring down the 7. 4 goes into 37. 8 times. Haha, I'm just kidding. 9 times. 9 times 4 is going to give us 36. And we get 1. Our remainder of 1. So this is the same as I to the first power, or just I. And that's it. And let's do one more. Uh, let's do number 6, I guess. So number 6, we have I to the 4th, which we know is just 1 plus I to the negative 12. And negative 12 divided by 4. 4 goes into negative 12, negative 3 times. Subtract, and we get 0. This is the same. I to the negative 12 is equivalent to I to the 0 power, which is also 1. So 1 plus 1 is 2. And there you go. That's it. Huh. Well, it said it was muted. Hopefully it's not muted anymore. I don't know what happened there. Okay, so complex numbers, it can be real numbers with imaginary numbers, or it could just be real numbers are also complex numbers. So like, for example, 1, 20, negative 500, those are all real numbers, but they're also complex numbers. Or you could just have imaginary numbers like I, 2i, to the second, I to the third, 5i, 20i, negative 7i. Those are all imaginary numbers. However, they are also complex numbers. Okay, so you can have both together or just one of them, and those are complex numbers. So we have a real part and the imaginary part. The real is the one without the I. Okay, so for example, we had 7 plus 11i. There you go. Or 7 minus 11i. Or 12. Or negative 6i. Okay, all of those are complex numbers. All right. And yeah, here, this is called a pure imaginary number, though. And yeah, because there's no real number with it. That's it. All right. Hopefully that made sense. If not, feel free to ask. Put this on the notes. And we have some examples. So here we're going to be adding and subtracting. And it's just like adding and subtracting binomials or polynomials. It's the same thing. You just want to combine like terms. So for number 9, we combine the real parts. So 3 minus 4. So 3 minus 4, it's going to give us negative 1. And then we combine the imaginary parts. Positive 2i plus positive 6i. So 2 plus 6 is going to give us positive 8i. And that's it. All right. And let's do one more and then one more plus and then we'll look at the subtracting. So same thing. Let's look down here at number 15. So look at the reals first. Negative 2 plus 5 is going to give us 3. And then look at the imaginary. We have 4i plus negative 4i. Oh, that's a 0i. Okay, so we don't technically need to write that. So it's just going to be 3. Because 0 times I is just 0. 0 times anything is 0. And there you go. That's it. All right, now let's look at some subtracting. So subtracting, I like to distribute first, okay? Otherwise, you might make some mistakes. So let's distribute that. Okay, this first one does not change. It still stays 0.5 plus I. We're going to distribute this negative, distribute to everything on the right side. Okay, so that becomes a negative. So that becomes a plus. And this is a negative 2i, sorry, negative 2. And that becomes a plus I. So I just distributed the negative, so change the signs. And here we have 0.5 plus negative 2 is going to give us negative 1.5. And then I plus I is 1i plus 1i is 2i. And that's it. Let's do one more subtracting and then we'll call it a, we can do some more if you want. Uh, I guess let's do 16. So 16, again, the first one does not change. 5 plus 7i does not change. The one that changes is the one on the right. So that becomes a plus. This becomes a positive 5. And that plus I becomes a minus I. All right, and then combine like terms. 5 plus 5 is 10. 7i minus 1i is 6i. And that's it. Put this on the notes. If you have any questions, feel free to ask. If you want to try those other problems out, yeah, give it a try. All right. Yeah, practice makes perfect. All right, and here it's the same thing, but this is with electricity. So if you go into electronics and you go into electric engineering, then there's one of the basic courses that you're going to take is like I don't know, electricity that talks about ohms. Um, so yeah, ohms is similar to imaginary numbers. Okay, so you can look at that similar stuff. And if you want to do that, just let me know. Okay. All right, now we're going to look at multiplying. So, oh, sorry, it is 12:20, so I'm going to stop and then I'll cover multiplying and dividing tomorrow. Yeah, okay.